Bismillahirrahmanirrahim. Welcome to the class of linear algebra. Today we are discussing into the application of most important application of linear algebra, principal component analysis. Last summary of the lecture, main focus we are into this lecture of principal component analysis, how to actually use into the dimension reduction in machine learning model and data science model using the principal component analysis. And the first part in the solve some mathematical problem of this topic, and secondly, practically implement of this dimension reduction. For example, 10 features model convert into the two-dimension and three-dimension data using the Python. Manually, we are using the parameters in 10 features and 13 features. Main algorithm of today lecture is abstract of this lecture. Principal component analysis is a fundamental dimension reduction technique in machine learning and data science. We comprehensive study of this, how to use a mathematical modeling, mathematical foundation behind the principal component analysis, and further solve into the sum of the application problem, how to image pixels or dimensions reductions, how to solve the other data reduction compression method using the principal component analysis. Firstly, we study why we use the principal component analysis method. Firstly, we are the linear dimension reduction methods from the high dimension data converted into the low dimension data. During the process, we preserve the variance, we preserve the data dimensions using the orthogonal, identify the orthogonal reduction principle. First, 5 to 3 things why we use the principal component analysis. First thing is the how to during the dimension reduction, all the features are preserve your information, and how to visualization of the dimension reduction model, how to deal with the best low variance from the nice reduction, computational, how to reduce training time and memory requirement of computational efficiencies and future extraction into the data. 3 to 5 things are most important into the principal component analysis. Main core idea of this mathematical intuition behind this model. For example, first mathematical model, for example, 2 dimension is the future and 3 dimensions of the problem. How to mean, for example, how to center of the data, how to shift of the data from this future during this process. For example, shifting the original mean from the data, and six rotation, finding new orthogonal axis and maximum variance, and finally discuss into the new mapping, any projection of the new, how to convert the 10 features data, for example, into the 2 dimension data. And during the data is all the information are preserved, sensitive information are preserved. Mathematically behind principle, first we find the eigenvectors using the covariance matrix. For example, we learn with the mathematics using behind how to, for example, one data set is given and data set convert into the covariance matrix. How to covariance matrix find the eigenvalues and eigenvector. After eigenvalues and eigenvector, how to convert the actual real world problem into the simple PCEs, for example, dimension reduction problem. So first step, step-by-step algorithm of this problem of machine learning. Firstly, we solve into this principal component analysis is the mathematical tool behind this model. For example, key mathematical concepts, how to use the covariance matrix. For example, covariance matrix is a simple xi in xj matrices into the n is a number of features given into the matrices, and xij and x bar is a mean of this matrix. And very in this simple example, in simple way, we say simple problem covariance matrix in the n dimension data set is a covariance matrix. Secondly, find into this covariant dimension matrix to the eigenvalues and eigenvectors. Discussing into the last lecture of how to find the eigenvalues and eigenvector, the 3x3 matrices, for example, of large matrices, for example, 4x4, 10x10 features, 100x100 features. we're using into the practical application. For example, using the language of MATLAB and Python, we help into the solve of these problem. For example, formulation of algorithm. Firstly, we standardize into the data. For example, we given a data set. Secondly, find into the compute into the mean vector. Thirdly, plot in the problem into the center of the data. For example, mean center into in this center, we plot into the mean of this matrix. Thirdly, compute the covariance matrix, and finally, eigenvalues and eigenvectors. We pick into this largest eigenvalues of this and normalize vector form, and then then convert into the pieces. For example, small problem in this understanding of the principal component analysis, how to use actually mathematical induction of this problem. Firstly, we given a data set in the number of features is 1, 2, 3, 4. Number of features is 4, and reduce the two-dimensional data into the one-dimensional data. For example, this data is given into the two-dimensional data. For example, first feature is x1 and second feature is x2. First feature is number of elements is 4, parameters 4, 11, and 13 and 5. And centrally, second elements is a 7, um, 11, 7, 4, 5, and 11. How the two-dimensional data is reduction into the one-dimensional data? This is the one pieces. Firstly, we compute into the mean. Mean, all the values are added in this mean is the first features. His mean is 8, and all the value added in the second. Find the second features mean and plot the data in a center. Center, convert into the center matrices and compute the covariance matrix. For example, here is a covariance matrix, and find the eigenvalues and eigenvector using the fundamental techniques of the find the characteristics equation of eigenvalues. These are two eigenvalues. One is 13.38 and second is a 6. We use into the largest eigenvalues from this dimension reduction modeling. Normalize of the eigenvectors. This is the here is a eigenvector, and convert the higher eigenvector into data reduction. Practically, I using the Python and show how to center of the matrices. How is a first principal component. In the first PC is values is minus 3.4, 3.7, 6.2, and minus 3.5. Using the Python, we are actually plot how to visualize of the dimension reduction model, and which are plot the pieces mean, and how to reduction of the actual model, how to shift rotation during the dimension reduction problem. I'm sharing your screens. For example, here is my screen. Here is my screen. For example, original data set is a 2D data set in plus PCs one. For example, visualization. Here is my original problem. The first graph in the left side is a PC1, is a mean is here. And second graph is convert into these pieces into the data model in the center line, show into the green, blue, and red lines into the center line means I am following. And pieces 1 and pieces 2 is the percentages, the maximum values of the pieces show is the 81.1%, and minimum PC2 value is 17.9 values. And data points are the this is the best fit model. For example, in right down color in the into the plot into the 93% is a best dimension reduction model from during the process. I am actually sharing your code in this lecture. For example, here is my lab code in this lecture. Screen sharing. For example, see the example in practical example of this lectures. For example, firstly, understand this next lecture, I'm detail discuss into the code, how to make this code and use from this data set. For example, firstly, installation of the pip install, matplot, and scikit-learn, and numpys. Three libraries are installed in systems. Secondly, for example, we use the four data points in this lecture. For example, four data points used into the data set. And step one, find compute main. Second, find compute central data. Same example. And third step, find the covariance matrix using the dimension ends. And finally, eigenvalues and eigenvectors. Second step is the descending orders. And use in this visualization, I'm used into the step of a matrix convert. All the applications are using Python. Just in the output, next lecture I am detailing discuss. For example, we find into the mean and central mean of the center data. Thirdly, we find the covariance matrix. Finally, we use a short eigenvalues, yani largest eigenvalues. Use the command from this short eigenvalues mean, we are converting into the decimal. For example, 4 decimal place, we pick into the 1 and 2 decimal places. And projection of the matrices. Here is a transformation matrices. Is a transformation matrix mean into the pieces, convert into the pieces. And third and last one, using into the, for example, lambda 2 is a 0 mean, this line is passing through the origin. Here is my future vectors. For example, here is my future vectors, and show here is my future vectors, manually solve and also solve is the Python. Here is my output. I'm sharing, I'm running in this code. Output of this code. Yes, here is a output. For example, 2D data set, for example, firstly, eigenvalue lambda 2 is equal to 0. Convert into the one dimension, two dimension, convert into the projection is one dimension. Variance per component is 98% and 17% pieces 1 and pieces 2. And for example, lambda 1 is a 70 and lambda 2 is a 0. Convert into the two pieces line into the one pieces. And thirdly, 10-point data set is 10-point data set is a given into this 2D space. The 10 points, the blue color is a show into the data points. And secondly, convert into the data point. During this process, 91% accuracy of this model of two-dimension model convert into the one-dimension pieces. And 10 features as converting into the one pieces, but the best performance is the model is 91%, 3%. Move into the my lectures, for example, in PDF. Okay. Okay. Next lecture is two data set and three data set. In this example, solve by this manually and also solve into the Python code. Next lecture, we were discussing into the, for example, this understanding this picture already in output of this Python code. Here is my center, convert into the, here is my data, central data. And thirdly, convert after rotation, convert into the, it's a red line and green line, center into the red, blue line is the mean, and mean is shifting, for example, rotation from the PC1 and PC2, and task convert into the PC1, red points, all the points is a mean, for example, data, central point, principal component analysis, and rotation models. Uh, Here is the PC1 is a first introduction lecture. In coming lecture, we are, for example, we use a data set. For example, we use a large data sets convert into the three dimension, two PCs, three PCs dimension. During the dimension process, solve the problem is mathematically and also solve the problem is practically in Python. Thank you so much. In the intro lecture of the series of linear algebra with application lectures. Coming lectures, we are more solve the practical example of principal component analysis with Python, also programming with the Python, and also solve this problem is a more complex mathematical problem, solve the principal component analysis. Thank you so much. Allah Hafiz.